Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another class of biology. I remember my own myself, Mr. Clawale A.O. I think we are enjoying our stay at home and I hope we are practicing all the precautions which we are said to practice, like washing our hands and sanitizing our hands. And then we should always maintain social distance. We pray this pandemic disease do not visit our homes. I mean, now today, we have an interesting topic before us, but before we move to the business of the day, can we briefly observe the first slide, which is the pictures we are seeing now? We have picture A, picture B, picture C, picture D, and picture E. What do they connote to you? Is there any relationship amongst this picture? Is there anything that the picture is depicting to you? What can you say about the picture? Now, interesting. Let's start with picture A. Picture A is having the soil and is having a plant which is moving towards the direction of sunlight. There is a meaning. The soil, the plant, which is the shoot system, is moving towards the direction of sunlight. While the one inside the soil, which is the root, is moving away from the sunlight. Please listen to these two statements here. We have towards and what? Away. That is for picture A. Let's look at picture B. You see, we have a lighted lamp, the lighted bulb. The lighted bulb now invites insects. These insects move on towards it. When the bulb is off, what will happen to the insect? They will move away. Another statement you need to keep: towards and away. Okay. In picture C, we have the lighted touch. The touch. Now, the touch is flashed onto a plant, especially in the dark room. This is used during an experiment. And then this plant will move towards the direction of the lamp. When the touch is not there, what will happen to the plant? It will not move towards the direction. So it will move away. So we have towards again and what? Away. Okay, let's look at the picture D. This is a mimosa plant. You can see a finger. Yes, when you touch this plant, what will happen? It will close up. And then after some time, it what? Opens. That is another illustration we need to decode. It's a message we need to decode. Then we have the tendrils of the stem and the tendrils of the leaf, which are attached to the stalk of which are attached to the stalk. Now, what happened to these leaves? What are they doing? Everything here in this picture, they are all responding to their environment. They are responding to the external stimuli. They are responding to what is in their environment. Just like as we do, we respond to some external stimuli. Our cell in our body, the internal body also respond to internal stimuli, which we can feel from the outside. And this is what will bring us to today's topic, which is cell reaction to its environment. How do we react? How does cell react to their environment? Do they move towards danger or they move away from danger? When they see something that can harm them, do they move? Do they still go? Yes, yeah, we can do it. Yes. Now we they still go towards it or they move away from danger? These are what we want to study in today's lesson. And you will see under it the meaning simply connotes sensitivity and irritability. To you, what is irritability? What does it connote? You just know. Let's look at it. There's two statements: sensitivity, irritability. They are the same thing, but we are used to irritability. Yes, like I said, in the Cambridge curriculum, they use, or let's say international curriculum, they use Mrs. Graham for the characteristics of living thing, and the S in the Mrs. is sensitivity. But in Nigeria here we use Mr. Ninja Dark, and this Mr. Ninja card, you have I there. The I is for irritability, which means all living things must be able to respond to both internal and external what? Stimuli. Now, how do they respond to it? That is what we want to study here today. I think we are going to enjoy it. Let's move on. Well, before we can proceed, we need to understand some concept, which is the stimuli, the cell, and the environment. These are the things that work together. Before the stimuli must come from the environment, and the cell must respond to the stimuli in the environment. Now, what is a stimulus? A stimulus is a change in the cell's environment that can make it change its activity. The change in the cell environment that can make the cell to change its activity. When there is a change in the environment, wow, this environment is not conducive. What will happen to the cell? The cell will rather what? I'm not moving away, I'm still here. The cell will move away. But when it is conducive, the cell will continue moving towards the cell, towards the stimuli, towards. And that is what we want to learn today. That is what we call the stimulus. The stimulus must cause a change in the cell activity. And again, the cell changes in activity is known as response to stimuli. When you move from one place to another, don't forget, for any cell to move towards any stimuli, it means it is advantageous to them. It is very advantageous to them. So for you to move from one place to another, it means you are responding to a stimuli. I'm going to give an illustration or example. Let's proceed. Okay, generally, animals respond very quickly and fast than plants. And when animals are responding, they move the whole of their body. But when plants are responding to external stimuli, they move the parts or their organs. And what are these organs? Examples of organs that plants use in responding to stimuli, they are the stem, the leaf, the flower, the tendrils, and the roots. These are the organs or the parts of the plant in which they use in movement. And that is why we have differences between locomotion and movement. Okay, let's look at the next slide. The types of responses. What are the types of responses we have? Yes, if we say animals respond to stimuli, plants respond to stimuli, how do they respond to stimuli? How can we categorize them? How can we know this is the type of response they portray? And that is what we want to study here. As I said, stimuli, there must be, it's just like a reaction, or response to stimuli is a reaction to the environment. And the reaction can be away or towards. When you are moving away or you are moving toward, when you are moving away, it means you are moving negatively to that response. And when you are moving toward, it means you are moving positively to that response. Let me give an illustration in this place. In your locality, your environment is just an illustration anyways. You have smokers in the environment, and you have those people that worship Allah very well. Yes, they go to masjid often and often during Salah. They don't miss Salah. Now, during Salah, will you prefer to move to those that smoke, or you go for Salah? When you're moving towards, if you during the time for Salah, and you know this is the time for Salah, you now want to move to those that are smoking, it means that place is advantageous. Don't forget that when you are moving towards, it is advantageous to you. But because you know Salah is advantageous to you, you rather move to what? Masjid, and move away from the what? The smokers. That means the masjid is a positive response, while the smokers is a negative response. Now, what are the types of responses we have? We have taxism, or what we call the tactics or the tactic. We have the tropism, or what we call the tactic movement, or the tropism, or what we call the tropic movement. We have the nastism, or what we call the nastic movement. In some literature, they can use nastic response. So it's still the same thing. Don't just see that, oh, I only learned nastic movement and not response. It's the same thing, please. Okay. I've mentioned this before. Responses of organisms to stimuli are usually advantageous to them. Yes, our Salah is advantageous to us on this earth and thereafter. Till Yamal Kiyama, it is advantageous too. So we rather move positively than negatively. So before you do something, think about the positive and negative and move to the positive side. Okay, let's move forward. And that is we want to study the types of responses. What are the type of responses? We have the tactics or the tacticism, or what we call the tactic movement or the tactic response. What is a tactic response? Okay, like the example I gave initially, when you move to the masjid for the smokers, that is, you move towards a masjid, and then you move away from the smokers because you cannot just withstand the odor. You cannot just stay in their environment. Yes, and then you know that the masjid is more advantageous than that of moving towards the smokers. Then you tend to move away from them. What are you doing? You move the whole of your body. And that is tactics movement or tropism. It usually occurs among animals. Though in some unicellular plants like Chlamydomonas that move the whole of its body can also exhibit this type of movement. Okay, what is tactics movement? As you can see on the screen, it is a directional movement. Why do we say a directional movement? Because it moves towards or what? Away. It moves positively or what? Negatively. Okay, it's a directional movement in which all the organism or freely moving parts of an organism moves from one place to another in response to external what? Stimuli. When we say towards and away, I think I've explained that. Okay, when an organism moves towards or away from a stimuli, it means they are moving what? Positively or negatively to the stimuli. Example of tactic movement is this. We have the phototaxism or phototaxics. Yes, what do you understand by the statement phototaxics or phototaxism? From the word photo, I think we've had the word photosynthesis time without number. Photo means light. It means that all of the organism is moving towards light, which is the external word stimuli. From the word phototaxis. Look at Iglena as an example. Iglena can move toward light when because Iglena can act as plant and animal. And if Iglena wants to manufacture food by itself, it can move towards light so that the chloroplast can absorb the light energy, and then food can be manufactured. And then if there is no light, the Iglena can move away and go feed with its mouth in the water. So it can move towards and what? Away. And that's what we say. In this type of movement, when Iglena is moving towards, we call it positive phototaxis. When it's moving away, we call it what? Negative phototaxis. Let's look at another example of tactics movement, which is thermotaxis. As the name connotes ourselves, the thermo means heat. Just like, okay, thank God we are all physics students, when we say thermodynamics, heat, thermal energy, heat energy. Yes, which can be derived from temperature. It means the all of the organism is moving in response to thermal, in response to heat in the environment. When they are moving in response to heat, this is found in bacteria. You know, bacteria cannot live more than 100 degrees Celsius. Not like a key. Don't forget, a key can also live in hot springs, very hot one, not the one like not the one like Ikogo say, but the hot one. Yes, that is boiling. A key can live there. They even live under them, but bacteria cannot live up to 100 degrees Celsius. So what will they do? Whenever they see that this place is heated, what will happen to bacteria? They will tend to move away. When they are moving away, what type of movement is that? We call it negative thermotaxis. But when they are moving towards, which means, we said, when the organism is moving towards or away, don't forget their movement or response must be what? It must be advantageous to them. So what is advantageous to bacteria is the negative thermotaxis. Another example of tactics movement is the hydrotaxis. Hydro, from chemistry, it means water. Yes, we all know that. And then this hydro means the movement of the whole of the organism towards what? Water. When they move towards humidity. Example is a wood louse moving towards the area of high humidity. When they move towards the area of high humidity, because we have that statement toward, it means it is a what? A positive hydrotaxis. Another example of taxic movement or taxism is chemotaxis. When organism, the whole of the organism is moving toward a chemical, from the word chemo, chemicals. Don't forget, some organisms, the chemicals can be injurious. Sorry, it's not when they're moving toward. When they respond to chemical, they can either respond positively or negatively. By benching with you, all organisms will respond to chemical negatively. For example, we have paramecium and amoeba. They move away from chemicals. When amoeba sight chemicals, what will happen to amoeba? Amoeba will tend to what? Withdraw the pseudopodia. Don't forget, they flap their pseudopodia when shoot and they move. But when they can perceive, oh, there is a chemical, they withdraw it. They form a circular shape, and then another what? Pseudopodia continuing from the back, and they move away. The same thing happens to paramecium. Paramecium will continue moving. When they feel it, they change what? Direction. And that statement is also called avoidance. They tend to avoid danger. So, like I said earlier on, please, let's always try to avoid danger. Do not move towards danger. Okay. Another type of response movement is tropism. Tropism. Now, what is tropism? Tropism is also a directional movement in which, it is not the whole of the organism. It is what? The part of the organism. And when we say the part of the organism, it means we are talking about what? Plants. Don't forget the other time I said only part of plants respond to stimuli, while the whole of animals respond to stimuli. It means tactic movement or the taxis movement can be observed amongst animals, while that of tropic movement or tropism can be observed amongst the plant. Now, what is tropic movement or tropism? This is the type of a directional movement in which a part of plant move towards or away from external stimuli. They move towards or away. Yes. Don't forget, their movement is advantageous to them. If they are moving toward, it is advantageous to them. If they are moving away, it is somehow advantageous what? To them. Okay, it depends on your understanding of the concept. Now, it is known as bending or slow growth movement. It is a slow growth movement. It is not that fast. Yes. And again, the stimuli to which plants respond in this way include light, which we've studied the other time, phototropism. But here we are not going to use taxis. It will be phototropism. When a plant is moving, when you have you put a grain of a seed now into the soil, the plumule will shoot out and the radicle will move downward. When the plumule is moving towards the direction of sunlight, what type of movement is that? We can, it is part of the plant, so we call it positive phototropism. But the roots, which is the radicle, the embryonic root, when it's moving downward, what type of movement or response is that? We call it what? Negative phototropism. That is when we are using phototropism 42 as the criteria. So it will be negative because it's not moving towards the sun, it's moving away from the sun, and that is what is advantageous for the root. So the root will move downward, which is negative phototropism. So another one is the touch, which is known as the thigmotropism. When you touch the animal, we tend to move away. Another one is gravity, which is geotropism. What do we mean by geotropism? This one is observed in what? In the roots. Now look at it. The other time we use photo, which is the light. This time around, let's make use of gravity. Now the roots will move, is it positively downward into the soil when we are using gravity, or negative? They will move what? Positively. Thank you, good of you. They will move positively. They will move positively inside the soil if we are using geotropism. So we call it positive geotropism. What about the shoot system, which is the plumule, embryonic shoot? How will they move when we are using the geotropism? They will move what? Negatively geotropism. So it will be negative. They will not move towards gravity, they will move away from the gravity. So that is That's about tropism. We also have the hydrotropism and we have the chemotropism. Okay, note, a tropic movement is described as positive or negative, just like I've been saying the other time, depending on whether the bending movement is towards or away. I've explained this earlier on from the direction of the stimuli, respectively. Below are examples of various tropic movements made by plants. Okay, let's go into nastism. Nastism. Sorry for this. I said below are examples of tropic movement made by plant. I've mentioned it earlier on, and the examples are the phototropism, chemotropism, hydrotropism, the thigmotropism, and the like. So these are the examples. Now let's go to another type of response, which is nastism. It's not when you say you are nasty. This is a movement or response to external stimuli. Now, this nastism is different from that of tropism and taxics or the taxism. How is it different? Because in nastism, it is a non-directional movement in which a part of a plant, don't forget, we are talking about plants again, in which a part of a plant move in response to light intensity. If the light intensity is high, they will move in response. If it is low, they change their response. So that's why nastism is different. So it's not the whole of the organism that move, just the part. And when we say the part, it means yeah, because it's a non-directional, we cannot have what? Positive or what? Negative. So it can move the light intensity, temperature, and what? Humidity. Note, it is neither positive or negative, like I said earlier on. Examples are 1. Closing of morning glory flower. When the light intensity is low, the morning glory flower will what? We close, because there's no light intensity for them to glow. So they will rather what? Close. It means at night or in the evening they close. Or when the light intensity is low, yes. Now another example is opening of the what? The petals of sunflowers during the day and closing of the petals at night. Opening of the petals of sunflower during the day and closing at night. This is also in relation to that of stomata. Yes, do you know stomata opens during the day and at night they close? Why? What type of movement is that? Nastism. Okay, let's look at it. Another one is folding of the leaflets of mimosa plant. That plant we saw the other time. That plant, the image we saw from the beginning, that mimosa plant, when it is being touched, what will happen? It will close. So, like I've said, this response to is just a one way. It's a non-directional. It's a one way. When you touch, it closes. When there is light intensity, oh, they blossom, they glow. Another one is closing of the leaflet of flamboyant tree during due to low light intensity. What is that about the nastism? Okay, I've studied that. The 3 types of response, the major 3 types of responses are taxics, tropic movement or response, and the nastic response. Let's look at the similarities between taxics and tropism. Don't forget, the reason why we want to study the similarities is because they are both directional movement. That is one. I think we get that. Okay, similarities. Number 1, taxics and tropism are 2 phenomena shown by organisms. Yes, they are shown by what? Organisms. Both plants and animals. Another one is they occur as a response to stimuli towards or away. They are directional. Another one is taxics and tropism are directional responses. Another one is both movement help organisms to survive in their environment. I told you their movement is because it is directional. It helps the organism to survive. The organism cannot move towards danger, like I said earlier on. So it makes the organism to survive successfully in the environment. And the differences between taxics and tropism. Look at the criteria. From the definition, taxics is the directional movement of animals as a response to a stimuli, while that of tropism is for the plants and usually part of the what? Plant. Another one here is the criteria is shown mainly by what? Animals. While the taxis is what? By land. The types, we have the chemotaxis, phototaxis, geotaxis. While in tropism, we have tigmotropism. That one is different from taxis. If we even have phototropism, chemotropism, we cannot have tigmotropism. We cannot have tigmo in that of taxis. Okay, another one is their example. Ants moving towards sugar, euglena moving towards light, and then for plants, plant shoots moving towards the light and the roots moving away from light, which we can call positive phototropism and negative phototropism. I think the similarities and differences of taxis and tropism, because they are both directional movement, they are well understood. Okay, let's continue. Differences between tropic and nastic. Why do we want to study tropic? We are trying to take one that is a directional movement, and that's one that is a non-directional movement. The tropic movement, it is a directional movement, while a nastic movement, it is a non-directional movement. The tropic movement response is either positive or negative, while nastic movement, the response is neither positive or negative, non-negative, please. Correct that statement in your note. It is not negative. Okay, it is not reversible. Why that of nastic movement can come back to it. After touch, when you touch the mimosa plant, what will happen to it? Do you know I don't want to. Okay, when you touch the mimosa plant, what will happen? It will fold up. Then thereafter, it opens. So it is reversible. The same thing to morning glory and the sunflower. So what happened during light intensity? What do they do during the day and at night? And the morning glory flower. Okay, response is due to cell toggle for tropic movement. It is due to cell toggle. It is not due to cell toggle, because like I use stomata to explain. When water move onto the stomata, is the one that will force the stomata to what? Open. And then when the toggle pressure is low, it what? Close. So it means nastic movement is due to cell toggle, while tropic movement is not due to cell toggle. Okay, another one is, it is a slow response. I think I've mentioned this, that tropic movement is a slow growth or response in plant, while that of nastic movement is a fast response. Okay, it is a growth movement. Yes, tropic movement is a growth movement, while nastic movement is not a growth movement. It's not moving towards. It's not moving. It's just changes due to the environmental environmental conditions. Okay, another one is response to unilateral stimulus, response to diffuse stimulus. Unilateral, that is one. When there is a stimuli, it can respond to that stimuli, but this one can respond to a diffuse stimuli. When you touch it, the whole part of that side will respond to it, the whole part. So that is that about the differences between tropic and nastic movement. Let's look at the environmental. This is another topic. I think we've understood the response and the cell reaction and their environment and the three major types of responses. Let's look at this topic, environmental factors that evoke response. Like I said the other time, I said due to some environmental conditions. Let's look at the environmental conditions that evoke response. We've been mentioning some of them. I think we are acquainted with the environmental factors. Example are the factors that evoke responses. They are the light, water, gravity, temperature, pH. These factors affect plants and animals in several ways. Equal exposure of plants to light diffuses their hormones equally. Equal exposure of plants to light, it diffuses the hormones equally, but unequal exposure of light to plants, it does not make their hormones to be what? Equal. It will become unequal. It means the hormone will now move from the lighter side to the what? to the dark side. And when they are moving from the lighter side to the dark side, they will cause what? A curvature. Because the hormone will be accumulated at the dark side to cause growth to continue at that side. Because the light side is already seeing light, while the dark side is not seeing light. It needs something to induce its growth. So it will now go there, and then it will cause what? A curvature, and it will bend. And how is it going to bend? It will now bend towards what? Light. That is why you have all these plants bending towards what? Light. Now let's look at what we have on the slide. The second paragraph. This makes the plant to grow upright. Yes. Placing a plant in an horizontal position causes an unequal diffusion of hormones. This will make shoot negatively geotropism. When we say negatively geotropism, it means the shoot, suppose, is not going downward. It is going what? Upward. So it will not go in response to the gravity. It will move what? Upward. Negatively geotropic by growing upward. But a plant that is starved of adequate light responds towards any source of light available. The shoot will respond positively to the source of light, while the root will respond what? Negatively to the source of light. In shaded area, smaller plants, in an attempt to get light from the top, grow taller. This is called etiolation. In an attempt to get light, they continue growing taller. What is making them to grow taller is because of the hormones. And what type of hormones? That is auxin. Okay, we are going to understand the concept in this part of the slide, which is the role of auxins in growth movement. That thing that makes the plant, the shoots to move upward and the roots to move what? Downward. The shoots to respond negatively to gravity, while the roots to respond, what makes the root to respond positively to gravity? What makes the shoots to respond positively to light, and what makes the roots to respond negatively to light? And that thing is auxin. Role of auxins in growth hormone. Auxins are the best known of plant hormones. The best known growth hormones of plants. They control tropism by stimulating growth in roots and shoots. I've mentioned this. Now, they are produced by the cells at the shoot tips. Why is it at the shoot tips? I think we've mentioned this. At the growing region, the mitotic region, the cell division, the place that exhibits cell division, that is the growing region. From where they diffuse to the growing region. Good, I've mentioned that. For example, auxins influence phototropic movement. What do we mean by phototropic movement? The movement of plant positively towards light, which is the shoot, and negatively away from light, in the following way. Now, how does this auxin work with the plant? Number one, auxins are produced at the tip of the shoot. That is nothing to doubt about. It is correct. Number two, they migrate or diffuse to the area of growth. They now, when they are produced at the tip, they now move to the area of growth, which is the what? The growing region or the mitotic region. Now, what now happens? The shoots will grow what? Straight, as long as there is equal concentration of auxin in all sides. Don't forget the other time we said when there's equal light shining onto the plant, what will happen? There will be equal diffusion. So the shoots will continue going straight without blending. Straight. But when there is unequal light being supplied, that was the next one. Unilateral illumination of the shoot causes auxin to migrate to the side of the shoot away from light. So auxin will move from the place, from the lighted side to the what? To the dark side. So that growth will also continue here. So the lighted side will be going what? Straight. While the what? The dark side, what will now happen? When auxin is accumulated, that's the next one, number 5. This increase in auxin concentration causes increase in growth or makes it faster on that side. Now the auxin is accumulated at that side. So increase in growth will now take place. And then it will now cause what? A curvature, which makes what? The plant to bend towards the direction of light. This eventually causes a curvature or bending towards the source of light, resulting to positive phototropism. Now, what will happen to the roots? It will be negative phototropism. That is just the role of auxin. Now we want to look at how auxin makes plants and the stem to move upward towards the direction of light, which is positive phototropism, and the root to move away from the direction of light, which is negative phototropism. That is what this slide is telling us. How light brings about tropic movement in stem and root of a flowering plant. It's more or less like the same role of auxin. We are just trying to explain that of stem and that of the root. Now, when unilateral light falls on the stem, what will happen? The auxin or the growth hormone is displaced from the lighted side to the what? To the dark side. It will move from the lighter side to the what? To the dark side. And it will become what? Accumulated. When it's become accumulated, what will happen? The increase in auxin concentration on the dark side increase growth on that side, causing the stem to bend towards the light, which is positive phototropism. Number 2, for the roots, the auxin is displaced from the lighter side to the what? To the dark side. That is when unilateral light falls on the what? On the roots. What will happen to the auxin? The auxin will be displaced from the lighter side to the what? To the dark side. Then what else will happen? The increase in auxin concentration retards growth on the dark side, causing the root to bend away from the light. Are you getting it? The increase in auxin concentration retard growth on the dark side. So on the dark side, instead of it to move upward, because there is increase on the dark side, the root will move what? Downward, causing the root to bend. There will be a curvature, and the root will now bend away from light. That is what? Negative phototropism. So that is all for the cell and its environment, the cell reaction to its environment. Thanks for listening. Please copy your note in your biology note. Peradventure you have any question, please use the comment box. Thank you very much and God bless you. Remember to always stay safe. Assalamu alaikum warahmatullahi wabarakatuh.